VSEPR, often pronounced VSEPR, stands for valence shell electron pair repulsion theory. This theory is about the shapes that molecules make. As scientists, we're interested in shape because molecules are just like us. They exist in 3D space and have particular shapes. And a molecule's 3D shape affects how it can stack together and interact with other molecules. The basic principle of VSEPR is that atoms want to arrange themselves as far away from each other in 3D space as possible, hence the word repulsion in the theory name. So let's have a look at some of the shapes that molecules make. When you're figuring out the shape of a molecule, always start with the central atom and then consider the things that are hanging off it. These things can be other atoms or they can be lone pairs of electrons, electrons that aren't bonded to another atom. So here we have one central atom with two other atoms hanging off it. These atoms want to be as far away from each other as possible, so they arrange themselves in a straight line with an angle of 180 degrees between each atom. This molecular shape is known as linear, linear meaning a straight line. Now let's consider a central atom with three things hanging off it. Remember, these atoms want to be as far away from each other as possible. The best way to do this is to form angles of 120 degrees between each outer atom. You can see that this configuration isn't linear. It's called trigonal, trigonal meaning triangle, planar, planar meaning flat. So the molecule is arranged in the shape of a flat triangle and we call the shape trigonal planar. Now, what would happen if one of the atoms was a lone pair of electrons? Lone pairs are felt but not seen. So they affect the shape of an atom, but you don't draw them like you draw an atom. So let's get rid of one of these atoms and replace it with a lone pair. We often draw lone pairs with two dots and a bubble around it. So it's felt and affects the shape, but is not seen. And again, the shape of the molecule is no longer trigonal planar. It's bent or angular. Now let's look at a molecule with four things hanging off a central atom. You'd think the atoms would want to spread themselves out like this, but that only makes a 90-degree angle between the atoms. Instead, to get as far away from each other in 3D space as possible, the atoms will arrange themselves like this. This gives the atoms an angle of 109.5 degrees between them. And this shape is called a tetrahedral. Tetra means four. And if you imagine that each atom is the corner of a face, that gives us four triangular faces. Now what would happen if one of the atoms was a lone pair? Let's get rid of this atom and replace it with a lone pair. Can you see that when we look at the atoms only, the molecule now makes a pyramid shape? So a molecule with 0 lone pairs is tetrahedral, and a molecule with 1 lone pair is called trigonal, because it's a triangular shape, pyramid, because it's a pyramid. So not trigonal planar, which means flat, but trigonal pyramid. If we have 2 lone pairs, this will get rid of one of the remaining 3 atoms, and you can see that the shape is now bent or angular. Remembering the lone pairs are felt but not seen, so they affect the shape that forms, but you don't take them into account when naming the shape of the molecule. And you might recognise this particular shape. It's the shape of a water molecule. Water has 1 oxygen atom, 2 hydrogen atoms, and 2 lone pairs. Let's keep going and have a look at a molecule with 5 things hanging off a central atom. Here's our central atom. 1 atom goes up, 1 goes down, and then from the middle, 3 atoms spread out like this. If we imagine that each of the outer atoms is the corner of a shape, that gives us a pyramid above and a pyramid below the central atom. So the name of this shape is trigonal because it forms triangles, bipyramid, bi meaning 2. Now there are lots of options for shapes with lone pairs. If we place a lone pair here, this will give us a trigonal pyramid. A molecule with 2 lone pairs will form a trigonal planar shape, and 3 lone pairs will mean a bent or angular shape. The last arrangement is to have a central atom with 6 things hanging off it. 1 atom goes up, 1 goes down, and then 4 atoms are drawn around the middle in a square shape. It's called octahedral because it forms a shape with 8 faces, 4 on top and 4 on the bottom, like 2 square pyramids stacked on top of each other. Once you start replacing atoms with lone pairs of electrons, you can see that the shape starts changing to square pyramid, square planar because it's flat, T-shaped, and linear. So that's how we predict the shape of molecules using VSEPR, valence shell electron pair repulsion theory.